Calculus 3, Part 2.2. Let fxy equal 2y squared ln 3x. Then delta f equals d dx equals 2y squared over xi plus 4y ln 3x j. Duf for 1 in direction of the vector 0, negative 1 is 0 times 2 times 1 squared divided by 4 plus negative 1 times 4 times 1 ln 3 times 4, which gives us negative 9.94. Let fxy equal xe to the 4y minus ye to the 2x. Then delta f equals, in this one we're going to use the sum difference rule, f plus or minus g prime equals f prime plus or minus g prime. E to the 4y minus 2y e to the 2x, I plus 4x e to the 4y minus e to the 2x j. Duf 1, negative 1 in the direction of the vector negative 1, negative 3 is duf equals delta f times u divided by the absolute value of u. So negative 1 times e to the 4 times 1 minus 2 times 1 e to the 2 times 1 I plus 4 times 1 e to the 4 times negative 1 minus e to the 2 times 1 j, all divided by the square root of negative 1 squared plus negative 3 squared, which gives us 2.26. Let fxy equal 2xy minus 3x squared plus 3y squared. Then an implicit equation for the tangent plane to the graph of f at point 2, negative 1. F of x equals 2y minus 6x, which gives us 2 times negative 1 minus 6 times 2, which equals negative 14. F of y equals 2x plus 10y, which gives us 2 times 2 plus 10 times negative 1, which equals negative 6. Z naught equals f2 comma negative 1 equals 2 times 2 times negative 1 minus 3 times 2 squared plus 5 times negative 1 squared. Negative 4 minus 12 plus 5 equals negative 11. Equation of tangent plane of given curve, f of x 2 negative 1 times x minus 2 plus f of y 2 negative 1 times y plus 1 minus z plus 11 equals 0. Z plus 11 equals negative 14 times x minus 2 minus 6 times y plus 1, which gives us negative 14x plus 28 minus 6y minus 6 equals z plus 11. Simplifying this further, we have negative 14x minus 6y plus 11 equals z. Let fxy equal 3x cubed minus 5xy squared. Then the direction which f is increasing the fastest at the point negative 2, 3 is f of x equals 9x squared minus 5y squared. X equals 9 times negative 2 squared minus 5 times 3 squared equals negative 9. F of y equals negative 10xy. Y equals negative 10 times negative 2 times 3 equals 60. At the rate of increase in that direction is the square root of 9 squared plus 60 squared equals 3 square root 409. Locate all the critical points of the function fxy equals 6x minus x squared minus 3xy squared. F of x equals 6 minus 2x minus 3y squared equals 0. 6 minus 2 times 0 minus 3y squared equals 0. So y equals plus or minus the square root of 2. 0 comma negative square root 2 and 0 square root 2 are critical points. 6 minus 2x minus 3 times 0 squared equals 0, giving us 6 equals 2x, giving us x equals 3, so 3 comma 0 is another critical point. A way to find the critical point would be to put x or y as 0 and simplify the equation. Consider the function f(x(y) equals x squared y plus y cubed minus 12y. d dx equals 2xy equals 0, giving us x equals 0 or y equals 0. d dy equals x squared plus 3y squared equals 12. Y equals plus or minus 2 when x equals 0. Therefore, 0, 2, and 0, negative 2 are critical points. When y equals 0, x squared equals 12, x equals plus or minus 2 square root 3. Therefore, 2 square root 3, 0, and negative 2 square root 3, 0 are critical points. D equals fxx times fyy times fxy squared. Fxx equals 2y. Fyy equals 6y. Fxy equals 2x. So D has the equation 12y squared minus 4x squared. F has no critical point at 0, 0. D 2 square root 3, 0 equals 12 times 0 squared minus 4 times 2 square root 3 squared equals negative 48, which is less than 0, so it is a saddle point. D times negative 2 square root 3, 0 equals 12, 0 squared minus 4 times 2 square root 3 squared equals negative 48, which is less than 0, so it is a saddle point. D 0, 2 equals 12 times 2 squared minus 4 times 0 squared equals 48, which is greater than 0. And fxx equals 2 times 2 equals 4, which is greater than 0, so we have a minimum. D 0, negative 2 equals 12 negative 2 squared equals 4 times 0 squared equals 48 greater than 0. Fxx equals negative 2 equals negative 4, so less than 0, so maximum. Find the limit if it exists or type in if it does not exist. Limit x, y goes to 0, 0, 2x squared divided by 3x squared plus 1y squared. As x, y approaches 0, 0, both the numerator and denominator of the function approach 0. However, the denominator can't be 0 because it would make the function undefined. Find the limit if it exists. Limit x, y going to negative 4, 4, e to the square root 3x squared 5y squared. So e to the square root 3 times negative 4 squared plus 5 times 4 squared equals 81,937.21. Find the given limit. Limit xy goes to e 0, ln x squared plus y squared. Ln e squared equals 2.